Hi everyone. So we haven't had science for a few weeks because we've been practicing for the play, but today we're getting back on with it. So this is our fourth lesson on forces and motion, and we're going to be thinking about friction today. So before I move to the next slide, just have a think to yourself. What is friction? Have you heard of this before? Can you think when it might be used? So friction is a contact force. So that means two objects have got to be physically connecting in order for friction to occur. And it resists the movement of surfaces. So friction is a pushing force that goes in the opposite direction to movement. So when an object is moving in one way, friction is pushing in the opposite direction. Friction is really important to our daily life, okay? And really, everywhere that you think about, there are applications of friction. For example, when you open a bottle, when you're doing the twisting motion to turn it, we have normally the little bits on the edges of the bottle, which are applying friction, which means that actually the bottle lid stays on. And when we turn it, the friction on our fingers stops our fingers from just slipping off the bottle. And the same when we're walking. If there was no friction when we walked, we would literally just be sliding along the floor. But because of normally the surface of a floor and the bottom of your shoes, there's more friction. So when you think about maybe if you walk on socks on a wooden floor, it's much easier to slip and slide because there's less friction in that situation. If you rub your hands together, really quickly, which you could try doing now. So put them together and rub them really fast. You should start to feel that they heat up. And that is because the friction of the surface of your skin is providing resistance, which is actually causing heat because of the movement of one object on the other, and the friction causes heat. So you can see from our picture that there's always the two different forces going on at once. So the pushing force, which is pushing an object forwards, for example, a car, a shoe, anything. And then in the opposite direction is friction, which is slowing the object down due to the surface or due to the bottom of the object. But normally motion is then going in the opposite direction. And we've got another picture of it here with the car. So the man is pushing the car and friction is opposing the motion, which is what makes it difficult to push the car because of the surface of the road and the friction of the tyres. So if we read this information at the bottom, it says there's always friction when the car is moving, even when you're not pushing it. So once, say you've pushed the car and then you've let go of it and now it's moving on its own, there is still friction. And the friction will cause the car to slow down until it eventually stops. Once the car has stopped moving, there is no friction at all. Okay, so friction only applies when there is movement. So when you're pushing something or it's moving on its own, then there is friction because there's movement. But when the friction gets so much that it stops, that means that there is no friction anymore. So here's a little question for you to just think about in your heads. If you were riding your bike over these three different surfaces, which one do you think would be the best path for going fast? Okay, so you want to think about the different types of surface and what would cause more or less friction. Another thing to think about is, what about if your brakes were broken, okay, and you could not stop very easily? Which path would you then want to ride down? Would one of them be a lot trickier to ride down than the others for your safety? That's just something for you to have a think about there. What I would like you to do today is, first of all, there's a video for you to watch which will tell you a bit more about friction. So you need to click on the link, and I've put that in the assignment. And then I want you to do a little bit of an investigation on your own. Okay, so you're going to need to find an object that's going to move on a surface. So ideally, it would be something like a toy car, something with wheels. But you could also have a ball, an orange, something that's cylindrical and will roll. Okay, then I want you to find some different surfaces in your house. So you could have a wooden floor, a carpet, a rug, grass, bubble wrap, something plastic. You might have some different things like a sponge, for example. I want you to have a go at pushing the object along the different surface and also letting go of it after you've given it a push and feeling the difference between them. Okay, are some surfaces easier to push on than others? How much effort do you have to use? Do you have to use more of a hard push on some surfaces? Does the object move quicker on a particular surface? Write down what you find, okay, and take a picture of the different surfaces you try and what you observe and you notice. What I would love you to do, if possible, is to try and set up a little ramp experiment. By which I mean, you need to get an object and put it at an angle so it's a ramp. And then you need to put different surfaces on the ramp. And then you're going to take your object, your ball or your car, and put it at the top and let go of it. And I want you to time how long it takes to get from the top of the ramp to a certain spot at the bottom of the ramp. So you'll need to have a timer ready. You'll need to decide where the start, stop point and the finish point is. You might want to ask someone to help you. And I want you to try that on different ramps and see, okay, which surfaces does your object move quicker? So I've put in some questions here. What do you notice from the times? Which type of surface did the object move quickest? Which did it move slowest? And then here I've got some picture examples for you. So you can make your ramp out of a bit of wood. You could use a folder. You could use an A4 bit of cards. And then you can find some different things. So like they've put a tea towel. You might just want to use some plastic. You could put on any things that you can find around the house. And I've also put YouTube links here to 2 different types of ramp experiment, and it demonstrates it. One of them is where they let go of it at the post-it note and time how long it takes to get to the second post-it note, and then the bottom link takes you to one where they just actually measure the distance of how far the object travels. So it's up to you what you want to do, and you can record this in your own way. So you can take photos, and maybe on the photo you could add some writing to say how long that that surface took to go down, or maybe you want to write your notes in your book, or you could write it on notes on your iPad and upload that to Seesaw. So I've said take a photo or a video of your investigations using the object on the different surfaces and your ramp, and then post the videos or photos on Seesaw with an explanation. So you need to tell me, what have you found out? What did you notice? What did you observe? And you also need to fill it in these sentences. Surfaces which are rough cause something friction. Surfaces which are smooth cause something friction. If an object is travelling along a surface which has more friction, the bike will go blah blah blah. If an object is travelling along a surface which has less friction, the bike will go da da da. Okay, so you need to type out those sentences, or you could screenshot this if you wanted and write the answers in. And that needs to go onto your Seesaw as well. So to conclude, for the lesson today, you need to upload some pictures of your ramp experiment along with your findings, which can be presented in any way you would like. And you also need to fill in these sentences to show me that you have understood how friction works.